Hey everyone, it's Mr. Zamora here, and just going to talk to you about exponential properties. All right, so let's get going. Exponential properties. So let's start by talking about a little bit about what an exponent is. All right, so an exponent is utilized. You probably remember that it's a little number as a superscript on top of a base, and what it means is you need to multiply this base to itself that quantity of times, the amount of times as the exponent tells you. So 3 to the 4th, for example, which is equal to 81, is the same as saying 3 times 3 times 3 times 3. All right, so that shows you. So 3 to the 4th means 3 times 3 times 3 times 3. That's how exponents work. And so with exponents come a number of properties, a number of patterns that we can find. And some are more simple than others. One of the first important ones to understand is that a number raised to the 0 power is going to be equal to 1. Okay, but in this video, I'm going to talk about two of the properties of exponents, and that's the product property and the quotient property. We'll follow up with a second video where we talk about the power property and negative exponents. So let's go. All right, product property. Well, let's start with numbers. This is kind of a review lesson, so let's see how this goes. If I take the quantity 5 squared and I multiply it by the quantity 5 to the 4th, well, 5 squared is 25 and 5 to the 4th is whatever it may be, maybe 625, I don't know. If you multiply these two numbers, you get the product of 15,625. Well, watch what happens when I raise 5 to the 6th power. 5 to the 6th power is 15,625. So it might make us guess, right? One would guess that 5 squared times 5 to the 4th is really the same as 5 to the 6th, which might mean that I can add those exponents, right? So I can say I can keep the base and add the exponents. Well, let's look at some expression. That is true. You can the product property basically says that if you're multiplying two exponential expressions with like bases, you can keep that base 5, and you can add the exponents. 2 plus 4 is 6, and hopefully you see that that is correct, 5 to the 6th. Okay, this works with expressions as well. So if I have a to the 3rd times a to the 7th, that's going to be a to the 10th. Add my exponents, keep my base. Add my exponents, keep my base. If I have b to the negative 4th times b squared, well, if I add those numbers, negative 4 plus positive 2 is going to give me negative 2. So I get b to the negative 2nd, which actually becomes 1 over b squared. That might seem a little bit weird, but we'll talk about it a little more in the second video when we get to negative exponents. For right now, as long as you know that you need to add the exponents if you have a common base. We can look at some expressions that have numbers, right? So if I have 3a squared b cubed multiplied by 5a to the 5th times b cubed, this will give me 15a to the 7th, b to the 6th. So you can see that the a's, I added the exponents to get 7. The b's, I added the exponents to get 6. And 3 times 5, last time I checked, 3 times 5 is 15. So nothing fancy about that. Believe it or not, that is the most missed part of this type of work. We get caught up with exponential expressions that we forget how multiplication and division actually work with numbers. So that's the product property. Moving right on along, the quotient property is sort of like an inverse to the product property, where we remember product property, same base, add the exponents. Quotient property, same base, but if you're dividing them, then you're going to have to subtract the exponents. Okay, so for example, 5 to the 8th over 5 squared, I can't in my mind think of how much 5 to the 8th is, all right? But if you take that huge number, 5 to the 8th, and divide it by 5 squared, which is 25, you get 15,625, which we had seen previously as 5 to the 6th. So it makes us sort of start to think, well, this is really 5 to the 8 minus 2, right? 5 to the 8 minus 2, which means I can subtract the exponents. Here's how it works with algebraic expressions. So if I have a to the 7th over a cubed, that's going to be a to the 4th, okay? Because I can say 7 minus 3. If I have 2a to the 7th, b to the 5th over 10a b to the 3rd, well, then numbers continue dividing the same way. 2/10 is 1/5. So, I can say 10 divided by 2 is 5. Keep the 5 in the bottom. A to the 7th over a, you're going to subtract and get a to the 6th. B to the 5th over b cubed, you get b squared. And that's a wrap. You can subtract from top and bottom. It's fantastic.